August 17, 1943. 30,000 feet above Schweinfurt, Germany. Inside the plexiglass nose of a Boeing B-17 Flying Fortress, Second Lieutenant Charles Bud Hubert hunches over a $12,000 Norden M9B bombsight. That's the price of 3 houses in 1943. Hubert's job: put a 500-pound bomb through a ball-bearing factory roof from 6 miles up while flying at 180 miles per hour through exploding 88mm flak shells. But this morning, Hubert has a problem. His bomb sight can't see. He would later recall, "I looked through the eyepiece and everything was blurred, fogged, like looking through a dirty windshield in the rain." At ground level that morning, it was 82 degrees Fahrenheit. At 30,000 feet, minus 43 degrees. A 125-degree temperature differential. Inside the Norden's optical system sat 32 precision glass elements, each ground to tolerances measured in millionths of an inch. And every single element was cracking from thermal shock. Microscopic stress fractures invisible to the eye, but catastrophic to optical performance. Of 230 B-17s attacking Schweinfurt that day, only 88 placed bombs within 1,000 feet of their targets. The rest? 1,200 feet off, 1,800 feet, half a mile. Bombs meant for factory roofs, obliterated apartment buildings, schools, a hospital. 36 B-17s were shot down. 360 men dead, missing or captured. Post-mission analysis identified the cause. Optical failure rate, 47%. Nearly half the bomb sites couldn't maintain focus at altitude. The problem wasn't the bombardiers. It wasn't the Norden design. The problem was the glass itself. Because every precision optical element in every American bomb sight, gun sight, periscope, and rangefinder came from one tradition: German optical glass. Specifically, formulations developed by the Carl Zeiss Foundation in Jena, Germany. The Germans had perfected borosilicate optical glass in 1884. 59 years of refinement. And in December 1941, when America entered World War II, the entire U.S. stockpile of military-grade optical glass would last 8 weeks at wartime consumption rates. 8 weeks. Germany in 1941 produced 140 tons of military optical glass per month. The United States produced 2 tons. Not 2 tons less. 2 tons total. 70 times less capacity than the enemy. The Americans who were supposed to bomb Germany couldn't see clearly enough to hit their targets, because the only people who knew how to make the glass were Germans. To understand America's blindness, go back to 1846. Jena, Germany. Carl Zeiss opened a workshop making microscopes. His problem: inconsistent glass, impurities, bubbles. In 1884, chemist Otto Schott discovered that adding boron oxide to molten silica created glass with remarkable properties: lower thermal expansion, precisely controlled optical characteristics. Borosilicate glass, the foundation of modern optics. Zeiss and Schott formed a partnership that dominated global optics for 60 years. By 1935, they controlled 89% of the world's military-grade optical glass market. The Schott catalog listed 247 different formulations, each specified to 5 decimal places. American dependence was total. 100% of fire control optics for Navy battleships. 95% of precision lenses. 100% of Norden bombsight prisms. All German glass. America had an optical industry. Bosch and Lohm made camera lenses. Eastman Kodak made photographic glass. But military optical glass that survived minus 65 degrees at altitude, then 160 degrees on desert airfields without cracking, that required material science that didn't exist in the United States. Military optical glass demands impossibilities. Refractive index precision to plus or minus 0.00005. 5 decimal places. Thermal expansion less than 5 times 10 to the negative 6th per degree Celsius. When you heat the glass 1 degree, it expands less than 5 millionths of its size. Why? Because if glass expands differently than its metal housing, thermal stress shatters it at altitude. The Norden bombsight required 32 optical elements per unit. Army planners estimated they'd need 127,000 bombsights during the war. That's 4,064,000 optical elements just for bombsights. Total military demand, 850 tons per month. American capacity, 2 tons. In October 1940, Zeiss stopped issuing export licenses. In June 1941, the last German optical glass shipment arrived. By December 7, 1941, Pearl Harbor, the U.S. stockpile would last 6 to 8 weeks at wartime rates. America was about to fight a global war, and the ability to see, to target, to aim depended entirely on technology controlled by the enemy. Germany had a 60-year head start and production capacity 70 times greater. George Washington Morey was born February 14, 1884, in New Brighton, Pennsylvania. Steel town. His father worked a rolling mill. No money, no connections. Young George was obsessed with rocks. Why did some melt at low temperatures? What happened when minerals cooled from liquid to solid? He earned a Ph.D. in geophysical chemistry from Johns Hopkins in 1910. His dissertation, The Crystallization of Silicate Melts at High Temperatures. Nobody cared. From 1912 to 1918, he worked for the U.S. Geological Survey, studying volcanic glass formation. He published 23 papers, read by perhaps a dozen geologists. In 1919, Corning Glass Works hired him, not because they needed a volcanic glass expert. They needed someone who understood glass chemistry fundamentally. By 1940, Morey had published 147 papers and held 23 patents, mostly on specialty glass that never succeeded commercially. Inside Corning, they called him the professor. Brilliant, but impractical. His salary, $4,200 per year. Mid-level researcher. March 15, 1941, changed everything. Colonel John T. Thompson, inventor of the Tommy gun, visited Corning. His question to President Amory Houghton, "Can you make optical glass?" Houghton replied, "We make cookware." Thompson said, "German cookware is bombing London. We need American glass that can bomb Berlin." Corning's consensus was unanimous. Optical glass was beyond their capability. The German advantage was insurmountable. George Morey was not in that meeting, but he heard about it. That afternoon, he walked into Houghton's office unannounced. "I can do it. Give me 6 months." Morey explained his reasoning. The Pyrex formulation he'd refined since 1919 was already borosilicate glass. 80.6% silica, 13% boron oxide. Remarkably close to German optical glass. The problem wasn't the formula. It was purity and homogeneity. Pyrex had bubbles, striations, impurities that didn't matter in a baking dish, but were catastrophic in a bombsight prism. His insight: we don't need a new formula. We need a new process. The board of directors voted 7-2 against proceeding. The arguments were sound. Zero experience. Zeiss had 60 years head start. Financial risk was enormous. But Houghton overrode them. "If we don't do this, there won't be a country left to sell cookware to." Morey built a small prototype furnace, ordered high-purity materials, Brazilian quartz crystal, Death Valley borax. It took 11 tries to get temperature control right. The 12th batch was clear. He sent samples to the National Bureau of Standards, labeled only C17. Dr. Clarence Peters, chief optical physicist, tested them against every German specification. His November 3, 1941 report concluded, sample C17 exceeds all German specifications. Refractive index precision superior. Bubble density less than 1 per cubic meter versus German standard of 15. Request manufacturer identification. When Peters learned C17 was modified Pyrex from a cookware company, he was stunned. 5 weeks later, Pearl Harbor. America was at war. And the only man who could make optical glass better than the Germans was a 57-year-old geologist who'd spent 30 years studying volcanic rocks. The German shop process was exquisite craftsmanship. Clay crucibles holding 500 kilograms. Wood-fired furnaces heated to 1,450 degrees Celsius, 2,642 Fahrenheit. Held for 18 hours. Manual stirring with ceramic rods for 2 hours. Then 30 days of controlled cooling in temperature-controlled rooms. Yield, 60% usable. Time, 8 to 12 weeks per batch. George Morey saw inefficiency everywhere. His solution, abandon everything. His furnace was a rectangular tank lined with 1,200 pounds of platinum. 48 feet long, 12 feet wide, 4 feet deep. Why platinum? At 1,500 degrees, almost every material contaminates glass. Platinum is chemically inert. Cost, $35 per ounce. That's $672,000 just for the platinum lining. The Army balked. Morey's response, you want clean glass or cheap glass? You can't have both. The furnace operated continuously. Raw materials fed in one end. Molten glass flowed out the other. Temperature zones controlled by 47 natural gas burners, each with thermocouple feedback. Precision, plus or minus 2 degrees Celsius. Bubble elimination was genius. Germans let bubbles slowly rise over 18 hours. Morey used vacuum refining. After melting, glass flowed through a chamber at minus 28 inches mercury. Low pressure pulled dissolved gases out instantly. Residence time, 4.5 minutes versus 18 hours. Result, less than 1 bubble per cubic meter versus 15. Homogeneity required mechanical stirring. But you can't penetrate a platinum tank with a motor shaft. Morey used magnetic coupling. Platinum propellers inside, rotating magnets outside. 17 RPM. Complete circulation every 14 minutes. Refractive index variation, 0.00003 versus German tolerance of 0.000012. Raw material purity was extreme. Brazilian quartz crystal, 99.98% pure, not sand. Each crystal crushed, washed 3 times in hydrochloric acid, dried in vacuum ovens. Death Valley borax, electrolytic grade. Alcoa aluminum oxide. Total impurity allowance, less than 0.02%. German tolerance, 0.1%. The glass flowed onto a water-cooled platinum roller, forming a continuous ribbon. 24 inches wide, 3/4 inch thick. It entered a 144-foot annealing tunnel. Temperature dropped 1.2 degrees per foot over 12 hours. The glass cooled slowly, eliminating internal stress. Compare the processes. German, 8 to 12 weeks per batch. Refractive index precision plus or minus 0.00005. Bubble density 15 per cubic meter. Yield 60%. Labor, 180 man-hours per ton. Output, 4 tons per month. Morey's Corning method, continuous operation. Refractive index plus or minus 0.000015. Bubble density less than 1 per cubic meter. Yield, 91%. Labor, 12 man-hours per ton. Output, 85 tons per month. 7 times faster. 3 times more precise. 15 times cleaner. 15 times less labor. When Dr. Peters at the Bureau of Standards tested C17, he couldn't believe cookware glass exceeded Zeiss specifications. But the data didn't lie. A 57-year-old geologist using 1940s chemical engineering had beaten 1880s German craftsmanship. Physics 1, December 8, 1941, the day after Pearl Harbor. The Army's requirement, 650 tons of optical glass delivered by December 1942. 12 months. Corning's current capacity, 0. The contract, $8.4 million. On January 15, 1942, ground broke in Parkersburg, West Virginia. Why there? Natural gas from local fields. Ohio River access. B&O Railroad main line. 300 miles inland. Safe from coastal submarine raids. Construction. 4,200 workers, 3 shifts, 24 hours daily. The primary building covered 340,000 square feet. 7.8 acres under one roof. Foundation, 47,000 cubic yards of concrete. Structural steel, 8,200 tons. Tank number 1, the prototype platinum furnace, was fabricated March to May 1942. Welding platinum requires pure hydrogen atmosphere. From May 18th to 22nd, 8 specialist welders worked 96-hour rotating shifts. 1 continuous weld seam. A single pinhole would contaminate the entire melt. First ignition, June 3rd, 1942. Stabilization, 11 days. On June 14th, Morey authorized the first production test. Raw materials fed in. The batch melted. Glass flowed. Morey cut a sample. Refractive index, within specification. Bubble count, less than 1 per cubic meter. Tank number 1 worked. Tanks 2 through 5 were built in parallel, August to October 1942. Each held 18 tons of molten glass. Each cost $1.8 million. By late October, all 5 furnace lines were operational. The machine shop held 340 grinding machines, custom-built by Cincinnati Milling Machine Company. Each cost $8,500. Total, $2.89 million. The specification, polished surfaces to 1/10 wavelength of yellow light. That's 0.000002 inches. Raw materials logistics were brutal. Brazilian quartz, 340 tons per month. Mined in Minas Gerais, trucked 180 miles to Rio, loaded on Liberty ships for 4,200-mile voyage to Charleston. Transit, 18 days of convoys avoided U-boats. In March 1942, the SS William Gaston, carrying 230 tons of quartz, was torpedoed. 11 crew died. 230 tons sank. Death Valley Borax, 85 tons monthly. Rail route from Boron, California to Parkersburg, 2,400 miles across 8 states. AAA, 1 priority, same as uranium for Manhattan Project. Labor was the final challenge. October 1942, Corning needed 2,870 workers in a town of 20,000 during wartime. Solution, women. Of 2,870 employees, 1,340 were women. 46.7%. Operating grinding machines. Inspecting optical blanks. Loading furnaces. Training program, 6 weeks. Average wage, $1.12 per hour, 30% above regional average. 1 hire changed everything. Rose Ruby, Czech refugee, had worked as QC inspector at Zeiss Jena from 1935 to 1938. When Germany annexed Sudetenland, she fled. She'd memorized the entire Zeiss quality control manual. Every specification, every tolerance, every test procedure. Ruby set up the QC lab. 100% inspection. Every element tested. Rejection rates December 1942, 34%. By June 1943, 11%. By December 1943, 3.7%. Better than Zeiss's 5 to 8%. Production ramped. December 1942, 18 tons. March 1943, 47 tons. June 1943, 89 tons. That month, Corning exceeded Germany's pre-war output. December 1943, peak, 127 tons per month. Total 1942 to 1945, 3,840 tons. 14.2 million optical elements. 127,000 bombsights equipped. Value, $287,001,945. $4.8 billion today. In 11 months, Corning built a factory from bare ground, installed equipment that didn't exist elsewhere, trained thousands who'd never seen optical glass, and began producing glass exceeding the world's leading manufacturer. The German 60-year advantage evaporated in less than a year, not through harder work, through engineered systems replacing artisan skill. The optical glass leaving Parkersburg wasn't finished bombsights. It was blanks. They traveled to Eastman Kodak in Rochester for aerial lenses, Bosch and Lohm for bombsight prisms, Frankfurt Arsenal for fire control optics, Kollmorgen for submarine periscopes. Transportation, railway express armored cars. 2 armed guards per car. The reason, sabotage fears. On June 8, 1943, a railway express car derailed near Harrisburg, Pennsylvania. 2,400 optical blanks destroyed. $340,000 lost. Investigation found a removed rail spike. Tampered ties. FBI arrested Otto Kuhn, a railway switchman. German immigrant. Pro-Nazi German-American Bund member. He was tried, convicted, executed September 1944. After Harrisburg, all optical shipments used military control rail lines. At Bosch and Lohm, grinding took 14 hours per prism through 8 abrasive grades. By mid-1943, they employed 3,200 workers on 3 shifts. Production, 1,800 precision elements daily. Those elements went to Norden's New York factory. Carl Norden, himself Swiss-Dutch, produced 1,800 complete bombsights monthly. Each required 140 man-hours assembly. Cost, $11,000. Classified secret, same level as radar. Getting sights to England meant North Atlantic convoys. Liverpool docks received American equipment. Convoys, 45 merchant ships, 6 to 8 destroyer escorts. Crossing, 12 to 16 days, zigzagging to avoid U-boat wolf packs. In 1942, loss rate, 8.3%. By 1943, 3.1% after Enigma decryption and escort carriers. On May 14, 1943, U-boat U-230 torpedoed the SS James Swan and convoy HX-237. Number 3 hold contained 840 bombsights, 12,000 optical elements. The ship survived, but seawater contaminated cargo. 600 bombsights, total losses. Value, $6.6 million. Corning received emergency replacement orders. 48-hour production run. 12,000 elements shipped in 6 days. The Pacific Theater faced different challenges. Longer distances. Heat. West Coast to Pearl Harbor, 2,400 miles. Pearl to forward bases for 1,000 more miles. The killer wasn't submarines. It was heat. Optical glass expands when heated. A 3-inch prism heated from 70 to 110 degrees expands 0.0008 inches. Enough to throw off bombsight alignment. Solution: refrigerated cargo holds maintaining 50 degrees. But refrigeration required electrical power, diverting generator capacity, slowing ships. By 1944, Tinian Island hosted over 1,000 B-29s. Each required 38 optical elements. On-site repair facility. 24 technicians with complete Corning inventory. Monthly consumption, 2,800 replacement elements. At Buttonwood, England, 340 optical technicians refurbished 600 bombsights monthly. At Tinkerfield, Oklahoma, 280 technicians handled another 600. The entire system was a continuous pipeline. Production fed fabrication. Fabrication fed assembly. Assembly fed depots. Depots fed bases. Bases fed combat squadrons. At any moment in 1944, 40,000 Norden sites existed. 8,000 in active use. 12,000 in depot maintenance. 20,000 in transit or storage. That's 1,280,000 optical elements. Everyone from Corning glass. break any link, and strategic bombing was at risk. But the chain held. Through sabotage attempts, through U-boat attacks, through tropical heat and Arctic cold, the glass kept flowing. By summer 1945, production at Parkersburg, 127 tons monthly. Depot refurbishment, 1,200 sites monthly. The pipeline operated at peak efficiency. March 9, 1945. Guam, 6:10 p.m. Major Thomas Power watched 334 B-29 superfortresses prepare for takeoff. The largest single-mission bomber strike in history. Destination: Tokyo. Target: Shitamachi District, Tokyo's industrial heart. Power's aircraft, Tailwind, was Pathfinder. His job: drop first incendiaries, marking the target. General Curtis LeMay ordered the attack at 5,000 to 7,000 feet. Not the usual 25,000. Low altitude meant better visibility. Also more exposure to anti-aircraft guns. But LeMay had done the math. Better accuracy meant more concentrated bombing. More concentrated fires. More destruction. Each B-29 carried 5 tons of M-69 incendiary clusters. Napalm bomblets designed to burn wooden structures. 1,665 tons total. But even incendiaries require precision. 7.5 square miles. If incendiaries scattered across 20 miles, fires wouldn't connect. Wouldn't create firestorm. Mission would fail. Power's bombsight, Norden M9 with infrared filter attachment for night bombing. The infrared prism was Corning glass ground by Bosch and Lohm. At 12:08 a.m. March 10th, Tailwind reached initial point. Tokyo Bay. Power transferred control to Bombardier Captain Robert Fling. Fling activated the Norden. Through the infrared eyepiece, Tokyo's waterways appeared as dark lines. The Sumida River, the Arakawa River, their intersection north of target district. Fling's post-mission report stated, optical sight functioned perfectly. No fogging despite altitude change from 9,000 to 6,500 feet. Temperature differential approximately 60 degrees. Infrared optics provided clear target identification. Corning's borosilicate had thermal expansion matching the aluminum housing. No stress. No distortion. At 12:15 and 8 seconds a.m., the computer signaled release. 48 M-69 clusters dropped. Impact point, 180 feet from aim point. From 6,500 feet at 200 miles per hour. 3 arc minutes error. Norden specification, 5 arc minutes. Well within tolerance. The incendiaries ignited. White magnesium flares marking the target. For 2 hours, B-29 streamed over Tokyo. Each bombardier used Pathfinder fires as reference. 1,665 tons of napalm fell on 7.5 square miles. The fires connected, created firestorm, winds exceeding 60 miles per hour, feeding flames. Street-level temperatures, 1,800 degrees Fahrenheit. Hot enough to melt glass. Ignite asphalt. 15.8 square miles burned. 267,171 buildings destroyed. Estimated casualties, 100,000 killed. More than Hiroshima. More than Dresden. More than any air raid in history. 1 million homeless. American losses, 14 B-29s. 4.2%. Post-mission analysis, 334 bomb sites used. Optical failures, 2.6%. Failure 1. Cracked prism from direct flak hit. Battle damage, not equipment failure. Failure 2. Fogging from crew using improper cleaning solution. Crew error. 332 bomb sites functioned flawlessly. 99.4% reliability. Compare that to German optical performance in 1943, 8 to 12% failure rate. Zeiss glass had higher thermal expansion. Rapid altitude changes introduced stress fractures. German sites fogged at altitude. Tokyo was followed by more. March 11th, Nagoya. 286 B-29s, 3 optical failures. March 13th, Osaka, 301 B-29s, 1 failure. March 16th, Kobe, 331 B-29s, 4 failures. March 19th, Nagoya again, 290 B-29s, 2 failures. Total, 1,542 sorties. 12 optical failures. 0.78% failure rate. Strategic effect. Catastrophic for Japan. January 1945 aircraft production, 1,740. April, 920. 47% reduction. July, 380. 78% reduction. Admiral Somu Toyota, Japanese Navy Chief of Staff, interrogated after the war, stated, "The precision of American bombing made dispersion of industry impossible. We could not hide from eyes that could see through darkness and weather." August 6th, Hiroshima. B-29, Enola Gay, Colonel Paul Tibbets. Bombardier, Major Thomas Farabee. The Norden M-15 had all Corning optics. Target, AIOI Bridge. At 31,060 feet, Farabee looked through the sight. He could see the bridge. Every detail. Crosshair steady. No vibration. No distortion. Little boy fell for 43 seconds. Detonated 1,900 feet above the city. Impact point, 800 feet from bridge aiming point. From 6 miles altitude. 0.15 milliradian accuracy. The atomic bomb didn't need precision. Blast radius exceeded a mile. But the psychological impact of precision was calculated. Japanese leadership would know Americans can put bombs anywhere. No city is safe. 3 days later, Nagasaki. Boxcar, Major Charles Sweeney. Bombardier, Captain Kermit Bean. Same Norden M-15. Same Corning optics. Cloud cover. Limited visibility. 30 seconds, fuel remaining. Bean saw break. Identified Mitsubishi Steelworks. Released. Impact, 1,600 feet from aim point. Japan surrendered August 15th. George W. Morey Jr., the inventor's son, was on Tinian in July 1945. Army Air Force's civilian technical representative. On August 5th, he personally inspected the Norden site aboard Enola Gay. Checked every optical element. His report, all optical elements within specification. Site approved for combat use. 36 hours later, that site aimed the atomic bomb that killed 70,000 instantly and ended the war. In his personal journal, August 16th, 1945, George Morey Sr. wrote, "The war is over. We made 14 million pieces of glass. I wonder if anyone will remember that we made something beautiful that was used for something terrible. Glass has no morality. It only reveals what we choose to see." August 16th, 1945. The Army canceled all Corning contracts. The emergency was over. At Parkersburg, production ceased September 1945. By January 1946, only 320 of 2,870 workers remained. The women who'd operated grinding machines were laid off. Rose Ruby, the Czech refugee who brought Zeiss knowledge, stayed until 1947, then returned to communist Czechoslovakia. She disappeared into that system. No records after 1948. Total wartime production, 3,840 tons. 14.2 million elements. 127,000 bomb sites. Value, $287,001,945. $4.8 billion today. The German optical industry was destroyed. Jena sat in Soviet occupation. Zeiss factory dismantled, shipped to Russia. The Carl Zeiss Foundation split. East Germany got Zeiss Jena under Soviet control. West Germany got Zeiss Oberkochen, rebuilt from nothing. The irony, in the 1950s, West German Zeiss licensed borosilicate glass formulation from Corning. The monopoly America needed a break now learned glassmaking from Americans who'd beaten them. George Morey received the Presidential Medal for Merit in 1946. His private reaction in a letter to his wife: "They gave me a medal for helping burn cities. I just want to make glass without bubbles." He returned to Corning, continued glass chemistry research. Died March 15, 1963, age 79. The New York Times obituary ran on page 37. For inches of text, it mentioned Pyrex. It mentioned wartime service. It didn't mention he'd solved the optical glass crisis that threatened to blind the American military. The Parkersburg factory didn't stay idle. In 1947, Corning converted it to television screen glass. The borosilicate formulation designed for Bombsights now made screens for I Love Lucy and The Ed Sullivan Show. The technology found new applications. 1948, Palomar Observatory's 200-inch telescope mirror. Corning glass. 1950s, ICBM guidance systems. Corning glass. 1960s, Corona spy satellite cameras. Corning glass. 1993, Hubble Space Telescope corrective optics. Corning HPFS 7980 ultrapure fused silica. Direct descendant of Morey's 1942 formulation. The glass that aimed bombs at Tokyo now aims telescopes at galaxies 13 billion light-years away. In 1955, absurdly, Zeiss Oberkochen sued Corning for patent infringement. Amount: $47 million. Corning's defense: "We were at war. You were the enemy. Patents don't apply." The court agreed. Dismissed 1958. The German company that armed Hitler sued the American company that defeated him and lost. The Parkersburg factory still stands. 340,000 square feet. Current use: auto parts warehouse. Historical marker: none. Local awareness: minimal. The platinum furnaces were scrapped 1962. Platinum recovered: $2.1 million. Used to pay plant closure costs. 1,200 pounds of platinum that melted glass that aimed bombs that won the war became cash for laid-off worker severance in 1962. History forgets logistics. It remembers generals, battles, dramatic moments. It doesn't remember the 57-year-old geologist who figured out continuous platinum melting. Doesn't remember the Czech refugee who brought German quality control to West Virginia. Doesn't remember women who operated grinding machines for $4 daily and produced optical elements more precise than Zeiss made in 60 years. But without them, the bombers would have flown blind. Bombsights would have fogged. Targeting would have failed. Strategic bombing would have been crippled. Germany entered World War II with a 60-year monopoly. Unbreakable knowledge. World's finest facilities. America entered with nothing. 18 months later, America produced optical glass superior in every measurable way, in quantities Germany couldn't match. That transformation happened because one man understood glass at molecular level, because one company bet $8 million on improving process, because 3,000 workers learned a new trade, because a supply chain from Brazil to California to West Virginia to Pacific operated without failure for 4 years. George Morey died thinking nobody would remember. He was right, but every smartphone screen uses borosilicate principles he pioneered. Every fiber optic cable benefits from his purity obsession. Every telescope relies on homogeneity techniques he developed. America had no optical glass in 1941. By 1945, it had the best in the world, and the man who made it possible died, thinking his contribution would be forgotten. Until now, 3,840 tons optical glass produced, 14.2 million optical elements, 0 American combat losses attributed to optical failure. Dr. George Washington Morey, 1884 to 1963. Glass has no morality. It only reveals what we choose to see.